Okay, here's another video showing you some more solutions to midterm number 1 review problems. In this video I start on problem 14. I'm going to start the problems on set theory here. And in 14 and 15 I'm giving you some sets, x, y, and z. Actually they're the same sets. And in 14 I'm asking you to write out the elements of various intersections and unions. And in 15 I'm asking you to tell me whether or not these statements are true, which are statements about various intersections and unions being either equal to each other or subsets of each other, that sort of thing. We'll see how far I get. I'll start with 14 though. And in 14, I have these three sets defined, and I've taken x intersect y. These are the elements common to x and y. A, C, and E. G, F, D, and B are not. Y intersects z. Here's the elements common to y and z. They happen to be A and G. X union y. We take everything in x, add it to everything in y. And everything in y is also in x except for g, so I just add the g to the set x. X union z, same thing. Z has a g in it, and the a and the d are redundant, and so I go a through g. Okay, and finally, x union z, that thing intersected with y. X union z is given right up above, a through g, and if I intersect that with y, a, c, e, and g are the ones that list. And it turns out that y is a subset of x union z, so y intersected with x union z is equal to y itself. Okay, you can see that one. Number 15 uses the same sets, and it has a through f here, asking you if the statement is true. And basically on these, when it's asking about subsets, I'm going to go ahead and draw out the exact set, which is the left-hand side and then the right-hand side, and then ask myself, is it a subset? And if it's not, I'm going to slash it out and say they're not equal. And indeed, that's what happens. X intersect y is ACE, whereas z is ADG. It's not a subset, so I say no. Z, here it is. Here's y union z. A, D, and G are all in y union z. So it is a subset, yes, for part B. For part C, is y a subset of x union z? I write them out. A, C, E, G. Is that a subset of A through G? Yes. For part D, is the set containing the elements A and B a subset of x intersection z? Well, x intersection z only has the elements A and D in it, and so it is not a subset. Finally, is the set with the element A in it a subset of y intersect z? Well, y intersect z is A comma G, and that does not equal A, so I slashed out the equal sign and said no. That one was asking about equality. And finally, part F, is A an element of y intersect z? Y intersect z is the set of A and G, and so yes, it is a subset. So no, yes, yes, no, no, yes for number 15. Let me go ahead and move on. I've got more time in this video to 16. And in 16 it asks for some orderings, and it gives you these sets ACE and XYZ. It asks for Z cross Z in Lex order. It asks for, is that it? Z cross Z in Lex order. That doesn't seem right. I think I'm missing part of 16 here. Anyway, I've got it all here on this page, the solution page. Okay, so I've got my sets. Here's Z cross Z, and it is in Lex order. That's just the way I do it normally. To help me keep track, and I start with the X at front, and then go to the Y in front, and then go to the Z in front. And for the second element, I cycle through X, Y, Z, X, Y, Z, X, Y, Z. That's my pattern. For X cross X, I'm going to do the same thing, except it's A, C, and E rather than X, Y, and Z. A in the front with an A, C, E at the back. C in the front with A, C, E at the back. E in the front with A, C, E at the back. That's already Lex order also. X cross Z. Now I've got the A's and the X's mixed, so I start with A at the front and I go X, Y, Z, then C at front, X, Y, Z, E at front, X, Y, Z. X cross Z in dictionary order. Well, the dictionary order is here. X cross Z is the same as the Lex order when they all have the same length. Dictionary order really only gets to be complicated when we have different length strings mixed in together. Otherwise, it's the same as Lex order when you have the same length string. Okay. Let's see. Part E asks for, it says to list the elements of x union x squared union x cubed. In other words, the set S here is the set of all strings or words that can be formed out of the letters A, C, and E of up to length 3. Starting with length 1, A, C, and E. Length 2, we have 9 of them, 3 times 3. And length 3, 27 of them, 9 times 3. Okay? And it asks, part E asks for them in Lex order, and that's what we've got here. A, C, E. This is length first Lex order. Sorry about that. Length first Lex order. And that is going this way, then this way, then this way, then this way, then to here, then to there, then to there. Hopefully that ordering is clear. Not now that I made my arrows overlap. Okay, hope it's clear. Finally, part F asks for S in dictionary order. Now it gets tricky, and you can see I had to scribble out a few things. Basically, I'm going to start with the A's. Certainly anything that starts with an A comes first. And it turns out there are 3 plus 9 plus 27, or 39 elements in S. And I can look at them as 3 one-letter elements, 9 two-letter elements, or 27 three-letter elements. Or I can look at 39 as 13 plus 13 plus 13, which is those that start with A, those that start with C, and those that start with E. Okay, so I can break that 39 up 2 different ways. In any case, I got 13 that start with A, then 13 that start with C, then 13 that start with E. And we're going to follow the same exact pattern on all 3 of them. We're going to start with A, move to AA, AAA, AAC, AAE, and then the ACs. And then I have 1, 2, 3, 4 ACs, 4 AEs, and 4 AAs and 1 A. And you can see the pattern I've used, so we're always in alphabetical order when you look at the first differing element in the string. And then I do the C's, and you'll notice that the second and third elements, if they exist, match those in A. Same thing with the E's. The second and third elements are all the same correspondingly down the list. A, C at the second and third, A, E, C, CA, CC, CE, just E, EA, EC, EE. And so here's all 39 in dictionary order, like this. Okay, I'll end here. That's problem number 16.